Alright, so lesson 3, solve by factoring. We have to learn how to factor quadratics. That's what we want to do. Factor things that look like this. X squared plus bx plus c. Alright, you guys remember how to do this? First off, what are factors? How about that? What does that mean? What are factors? Good.
I guess it's like what makes it zero. So they're like solutions to.
You're thinking ahead. You're thinking. I'm saying what are factors?
Number that's multiplied.
Okay.
That's being multiplied.
Okay, you're very close. Very close. Let's say this. If I say what are factors of 20? What am I asking you?
What makes 20?
What things multiply together to make 20? And you would say 10 times 2. These two things are called factors, right? 5 times 4. Those are factors. Now, when it gets to this is a little more complicated. What are factors of x squared minus 9x plus 20? What does that mean? What multiplies together to give you x squared minus 9x plus 20? So the question is, how do we do that? I'm guessing people have forgotten. That's okay. So I'll show you. If you think of it like this, if you like write that down, here's what you want to write beside it. Find factors of c. So you should know what that means. Factors of c. What multiplies to get c? That do what? You remember? Those two factors have to do what?
That make up B.
Okay, that.
Add up to B.
Yep, add up to B. Keys right here. Factors of C, what multiplies to get C, and it also has to add to get B. If it doesn't do both of those things, you're not right. All right? Let's take a look. This one right here. Let's factor this expression. Anytime you see x squared plus bx plus c, which you see right here. Oops. Okay. Anytime you see this, think of b and c here. Okay. Factors of, let's just write it out in words here. Factors of what?
20.
Factors of 20. Factors of c, that's c. That add to what? Negative 9. So those are keys. Make sure you bring the signs with it. So that was positive 20. That was negative 9. It's minus 9, but we change it to negative 9. Okay? That add to negative 9. So here's what we do. Make a little list. Okay? You can make a chart. All right? Factors of 20. Okay? So factors, I put on this side. And then add to negative 9 on this side. Okay. Factors. What two factors you think of first? You probably think of 2 and 10. What do they add to? 12. So does that work? No. Next factors.
5 and 4.
5 and 4. What do they add to? They add to 9. Is that okay?
No.
Not quite. Yeah, they have to add to negative 9. So therefore we have to change our factors up to?
Negative 5 and negative 4.
-5 and -4. Do those make positive 20? Yes. Do they add up to negative 9? Yes. This is what you'll be looking at now. Okay? -5 and -4 add up to negative 9. So here's what I do. I set up a shell here. Since it's x squared, I'm just going to do this. X times x gives me x squared. Since it's -5 and -4, all I do is this. -5, -4. That's it. Okay, that's all. Now this one was the first one. They'll get harder. Don't worry. All right, Jordan. Okay, this. What is this right here? What are these? Yes, that's our answer. But what are they? They're factors. Why are they factors? Because this factor times this factor gives me this guy. Alright? This times this gives me this. Alright, just like 10 times 2, those are factors of, gives me 20. This times this gives me this. Okay, you try letter B. X squared plus 3x minus 12. Factors of C that add up to B. Go ahead. I like these. These are like a little puzzle almost, you know? Okay, what numbers do this and they do this? Okay, here's my answer. And this can be, you know, some people can do this in their head pretty quickly, and that's good. I'm not gonna make you show work for these two right here, okay? But if you did, you know, show me the bottom left-hand side. That would be your work. Okay, factors of negative 12. That's factors of C that add to positive 3. Okay, so you got to think a little bit. What are factors of negative 12? First things I think of, negative 4 and 3. But that doesn't add to 3, does it? So those are out. Next?
6 and 2.
6 and 2. So 6 and 2 make 12. So we got to make one of them negative. Doesn't matter which one? No. Okay, negative 6. Negative 6 and positive 2, what did that make? Makes negative 4. Is that good? No, right? What about if I change the negative to the 2 instead? Doesn't matter, does it? It just changes this number to positive and negative. That's all it does. Okay, so what did you find? Which one is it?
No.
Factors of negative 12 that add up to 3? Anybody? Okay, you could if we wanted, well, not for factoring, but if we wanted the solutions, yes, we would. For factoring, it has to add or multiply to get negative 12 and add to get 3. You find that?
No.
Okay, some people forget to do the obvious 1 and 12, but still that doesn't help us. Okay, 1 and 12. Yeah, we don't want decimal. When we factor, we'll never factor with decimals. So that's nice for you. No decimals there. So you got to think of whole numbers. Multiply to negative 12, add to 3. There aren't any. So therefore, okay, now there's one of those things that we weren't looking for a solution, right? What are we looking for?
No.
We're looking for factors. So therefore, if I said factor 17, what would you do? 1 and 17, but really it's prime, right? 1 and 17. This one is like prime. There's nothing that multiplies together to give you x squared plus 3x minus 12. Nothing multiplies together. So you could say not factorable. You could also say prime as well, but you could say not factorable. Okay? Write that down. Not factorable. There you go. Any questions there? Factors of C that add up to B. That's all you got to think. Alright? That's it. I like this section. I like doing them for some reason. Alright. Oop, you already saw that one. Let's try this one. N squared minus 3m plus 9. We got
Not factor.
factors of positive 9 that add up to negative 3. Don't be too quick. Don't be too quick to say not factorable, because that happens a lot. People just do a couple, but this one isn't. But just telling you, play with it a little bit. Okay, factors of 9 that add up to 3. I can only think of 1 and 9, and that won't give me negative 3. I can think of 3 and 3. But that won't give me negative 3 either, so you're done. Not factorable. Okay? Or cannot be factored. Either one. Alright, this one here. Go for it. Okay, what you got? Let's see. Who got? John, what you got?
9 and x.
Full answer.
X plus 9 and x plus.
I might take a point off for that. You know why?
R.
Yeah. Just be careful. Be careful. It's R, so make sure you guys end with R, right? So, negative 63 and positive 2. Factors in negative 63, was it? Negative 9 and 7? So, if you multiply these two, you got this. But, if you add those two, you got negative 2, not positive 2. So, switch out the negative, right? So, 9 and negative 7, just like you said. So, put it final answer, R plus 9. R minus 7. Just put these two things in the form here. These two are factors of the original. They multiply together to get it. Okay. Alright, factor with patterns here. Now look at this one. X squared minus 49. What isn't there? B is not there, right? X squared, what is it? X squared plus bx plus c. There is no bx. So therefore, what do we do if there's no bx? Okay, so one way you could think of it, Stephen, right there, he says b is equal to 0 and c is equal to negative 49. Yeah. Yep. You can think of it like that. So what multiplies to get negative 49 but adds to get 0? You could probably think of that pretty quick. Okay? So negative 7 and 7 multiply to get negative 49, and they add to get 0. That's one way to think of it. Okay? And, you know, the other way is just kind of looking at this and saying, this is a difference of squares. Look at this. This is a square, obviously. It says x squared. And this is a square. Right? What is it? 7 squared. So this becomes x squared minus 7 squared. This is a difference of squares. So what we do with this is there's a formula for this. If you ever see a squared, something squared minus something else squared, you could do this with it. A plus b, parentheses, a minus b, parentheses. Okay? You're going to have to know that. You really want to know this, okay? Because it's a nice little formula to know. Okay? Alright, so if you ever have something squared minus something else squared, just pull it apart and say, okay, well, what's A and what's B? Like this case right here. X squared. What's A? A is X. What's B? Well, B squared, so B is just 7. So we got X plus 7 using the formula and X minus 7. There you go. Or you can think of it Stephen's way too. That's fine. No problems there. Okay? But you'll definitely want to know this for later for hard stuff. For the hard stuff, you won't be able to use that little b equals 0 and c equals negative 49. Okay? So please know difference of squares. I would definitely write that on your paper. Difference of squares. There you go. Okay? Let's see another one here. So special patterns. All right. So look at that one. Actually, you don't even need to know that's a special pattern. You're going to do it the same. You can do it the same way you did. Go ahead. Do it the same way you just did the other ones. Factor. It's special because how you write it is a little bit different than the other ones. Do it the same. Factors of 36 that add up to 12. What would you say they are?
6.
6 and 6. Final answer, D plus 6. Yeah, D plus 6 is what people will probably write first. But then D plus 6 makes it D plus 6 squared. That's why it's a special pattern. It's a perfect square. This thing right here is a square. That's why it's special. Okay? So really that's called a perfect square trinomial, and this is a difference of squares up here. So know those ideas. Perfect square trinomial and difference of squares. Alright, some more factoring. This one right here. Same process. Go ahead. Alright, here we go. Factors of 169. You might have had to use your calculator for that one. What are they?
-13.
Yeah, if they want to add to negative 26, that's negative 13 and negative 13. So z minus 13, z minus 13 is z minus 13 squared. Another square for you. Okay? Alright, example 2 done. Factoring with special patterns. Okay, so difference of squares. Perfect square trinomials. Now, what I taught you all that for is so you can solve equations by factoring. Okay, so look at that equation right there. If you want to solve this thing, oh, notice one word here. What are the roots of the equation? You want to write this down. Roots are the same as what are the solutions to the equations. Knowing your math vocab is very important, because when I put those on a quiz and test and people don't study those little things, people say, I don't know what to do. He didn't teach that. Okay? Whatever. Okay? Same thing as solutions. What do? You want to factor this right here. Go ahead and factor that. And then write it down.
Let's see.
Factors of negative 36 that add up to negative 5. So, what are those two factors? Negative 9 and positive 4. Now here's what people will do. People will look at these right here and say, okay, negative 9, positive 4, answer. Not right. What are these supposed to do?
Add up to 0.
These are supposed to lead us to the what?
The fact.
The factors. Let's write out the factors. What are the factors? X minus 9. X plus 4, right? Equals, over here, equals 0. Now, here's the deal. You're going to use a property to solve right now. Easy property. A times B equals 0. If A times B equals 0, then A could equal 0, or B could equal 0. This is the zero product property. So we're going to use that right now. How are we going to do that? Well, this is like your A. A times B equals 0. So A could equal 0, so I'm going to write it down. X minus 9 could equal 0. Or X plus 4 could equal 0. Now what? Now?
Find x.
Find X. Solve for X. Plus 9 plus 9. X could equal 9. Or
Negative 4.
X could equal negative 4. Notice those answers are what? opposite of what we chose up here, right? So don't think too quickly. These are just the factors that lead us to this. Then you solve this and you'll get this right here. Alright, x equals 9 or negative 4. You just solved an equation based on the zero product property and based on factoring. So if you can factor, it makes it a lot easier. Or we could use something else. You remember what you could use with every quadratic? Yeah, calculator.
Standard form.
What method could we use to solve? Instead of factoring, we could always use something you've probably dealt with
System.
before. What?
System.
No, only one here. No system. Quadratic formula. You guys done that before? Quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Yes? You could use that anytime. But when you get to factoring, it actually makes it a lot easier.